Hello everyone, in this video tutorial we're gonna visually investigate the association between elevated blood lead level in children and median age of household in the state of Ohio. This is an application of GIS in the studies of effects of heavy metals on human health, which is an important topic in environmental health. So previous GIS-based researchers have found that old housing is a common risk factor in elevated blood lead level in children. For example, in this paper, which published in International Journal of Environmental Research and Public Health, with the title of Exploring Childhood Lead Exposure Through GIS, which is a literature review, if you scroll down in this paper and find Table 1, so Table 1 provides a summary of the studies with common risk factors and major findings. They used GIS for their studies. For example, in the Tennessee in the year 1998, they found that old housing is a common risk factor, okay, with different type of GIS analysis. In Kentucky, in the year 2001, again, old housing was a common risk factor. In South Carolina, 2003, old housing. In Atlanta, Georgia, old housing. In Rhode Island, old housing. So you can see old housing seems to be a common risk factor in different part of the United States for elevated blood lead level in children. But there was no previous research conducted in the state of Ohio. So in this study, we're going to visually investigate the association between old housing and elevated blood lead level in children, okay? So the first step is that we have to download the lead data in children, okay? So let's open up your Google and type Ohio Department of Health. And so the first link is Ohio Department of Health, odh.ohio.gov. Let's open up this link. And in this website, if you go ahead and select data and stats, and after that, if you scroll down and select Ohio Public Health Data Warehouse, so here the source of the data, a variety of source of the data. So if you click on next, and here is lead data, okay? So here there is a description of the data. This dataset contains data related to blood lead testing for Ohio children from 2016 to present, which is updated daily, and some description like no level of lead in body is considered safe. Medical attention is needed when a child under 6 years old of age is confirmed to have an elevated blood lead level of 5 microgram per deciliter or higher. Okay, so elevated blood lead level means that a child under age of 6 has a blood level of the 5 microgram or higher. Okay, so basically every year they test a number of the students for each county, and also they see how many of them they have elevated blood lead level. Okay, so these are also more information about the data set that they have. Okay, so we want to download the number of the children for each county that are tested, and then we want to download how many of them have elevated blood lead level. Okay, so if you go to the reports tab here, so we have number of Ohio children less than 6 years old tested for lead from 2016 to present, and also among these people, some of them have elevated blood lead level, okay, which means is greater than or equal to 5 microgram per deciliter from the same study period. Okay, so let's start downloading the number of the Ohio children that were tested for lead level. So if you click on this icon, and then if you go to the select row and column of variable, so our row will be location. We want to have the data for at the county level. Okay, so the location should be based on the county. And for columns in the data set that we want, so we want to have lead testing, how many testings have been done. Okay, so we don't want to specify a year, so we want to have the number of the testing for the entire period of a study. So if you now click on export data, so it and then click here, show in folder. If you open up this file, or we can copy this file and paste it in lab 6 folder, and here if you open up this file, so you can see that for each county in Ohio, so we have I think 88 counties in Ohio. For each county in Ohio we have number of the tests and number of the test for the children, or number of the children tested for the blood level. Okay, and so this one doesn't have any information, so we can remove this one. And this one is sort, I don't know what does it mean, so let's remove this one as well. So we have for each county we have number of the tests conducted, right? But the problem is that, so this one is not a good indicator, because some counties there, if you look at the values, there are significant difference between the number of the tests conducted. And this is because some counties that have higher population, for example Cuyahoga County has higher population, also number of the tests is higher. So which we want to also know how many of them were confirmed, and then we calculate the proportion or percentage of the county that were tested positive for the elevated blood lead level. Okay, so we have, so this one is total test. Okay, total, so we use underscore because we want to import this data into ArcGIS. Okay, total test for blood lead level. Okay, but we also need to have the confirmed elevated blood lead level. Okay, so in the Ohio Department of Public Health dataset website, again here, Ohio, next, lead data, reports. Now to the second option, elevated blood lead level. So we want to find out how many of them were elevated blood lead level. So if you click on here and then go to the select row and column variable, so again our row will be based on location and county, and the column has to be lead testing, but we want to know elevated blood lead level. Okay, so we can remove this one, we don't need this one. So if you click export data, so now if you open up this CSV file, so we can see that the values are smaller, much smaller, right? So we have elevated blood lead level, right, for each county. We have 88 counties in Ohio. For each county we have, among the children have been tested, these are number of the elevated blood lead level. Okay, so we want to have these two column. Okay, so we just, let's copy these two column and paste it in the, so let me remove it again. So this one was total test, score test conducted, and we downloaded this one, which was confirmed cases or elevated blood lead level, and we want these two column, right? I want to copy that in here. Okay, I clicked on copy, and paste it here. Okay, so make sure that both of them, they refer to the same location. For example, Adams, this one is total test, this one is elevated, total elevated, right? Or elevated. So among the 1,258 cases, 32 of them were elevated. So just make sure that they refer to the same location, okay? So we can compare that. I think it seems like they both refer to the same location because we downloaded it from the same source. So yes, I think they both refer to the same location. So I can remove this field now. Okay, so we have total number of the cases and we have elevated number of the cases. So now I want to create a new column with the name of proportion of the elevated, right? Proportion of elevated. What is the percentage of the elevated cases? Okay, so 32 divided by 1,258. Okay, so I want to divide 32 divide by this value, which gives us 2%. So you can also multiply this by 100, which gives us the value based on the percentage. So 2% of the children which were tested for blood lead level, they had elevated blood lead level. So if you apply this for all of the cells, so some counties, for example, Cuyahoga County's 8% of the children, they had elevated blood lead level. So there is differences between these values. So we have the percentage of the elevated blood lead level. Okay, so that's the first step. So we have the elevated blood lead level percentage of them. In the lab 6 folder, there is a CSV file which I obtained the data from the US Census Bureau. So this one shows the age of the household, the median year of the age of the households in Ohio. Okay, so for different counties in Ohio, we have median age of the households. Okay, for example, the age of household in Adams County is 1981, the median value, and so forth, so on. So what I'm gonna do, I want to remove this, the first line, and I don't need ID1, ID2. Remove it, so we don't need the margin of error. Remove it. So let's copy these two fields and paste it in our data set. Okay, here. So again, make sure that they refer to the same location, Adams County. So for the Adams County, the age of household is 1981, the median age of household. So let's compare these two. So it seems like they both refer to the same counties. They both the age of household and also the blood data. They refer to the same county. Let me check. So yes, so now I can remove this one. So for each county we have the proportion of elevated blood lead level, and also we have here I can change this to a year underscore household. So this is the median year of the household for each county in Ohio. Okay, so using this CSV file, because it has the location information, I can bring it into ArcGIS and make a map and investigate the association. Okay, so now our data set is almost ready to be imported into ArcGIS because it also has the location information. We can use this information for bringing into the ArcMap, and also we have the proportion of the elevated blood level. There is no space, there is no special characters, so it can be easily imported into ArcGIS. And also we have year of a household for each county in Ohio. Okay, so let's close this and let Ohio. So in the ArcMap, let's click on add data, connect to folder of lab 6 data, and then add the counties Ohio. So here is the counties of Ohio that we use this shapefile to join the information of the lead data to this shapefile for making the map and investigate the associations. So let's add the data, the CSV file that we just prepared, lead Ohio. And if you open up the attribute table of it, so we can see that for each county in Ohio, we have 88 counties. So we have total number of the test, blood level tests. We have also number of the elevated blood level tests among the total tests, and also the proportion. So these are the proportion, and also the year of the household, the median age of the household in for each county in Ohio. Okay, so if I want to make a map from this and also from this file, I have to join this CSV file to the counties Ohio, because this one doesn't have any geography information or spatial structure. So for the join operation, as you know, we have to look for a common field, the field that carries the same information. Which field is common? So this field is not, we don't have this field in the other one, but we have the name of the counties in this one, right? So county name from the CSV file, and if you open up the counties Ohio, so which field? The name field, name or name SAD, this one, name, because for the CSV file it didn't have the Adams County, right? So the value has to be exactly the same, the information. Okay, so here from the CSV file we have name, from the shapefile we have name, and from the CSV file we have county name. Okay, so right click on the counties Ohio, join and relates, join, and from the shapefile we have name, and from CSV file we have county name. We want to keep all records after joining, and then when you click OK, so what happens? So the information, the CSV file appended to the shapefile. If you open up the attribute table of the counties Ohio and then go to the very right part of the table, we can see that. So this information has been added to the shapefile. Now we can make a map from this, right? So we have all of the information. We have the year of the household. We also have the proportion of the elevated. Okay, but we know that the result of join operation is temporary, so we have to make it permanent by exporting, right? So right click on the shapefile, data, export data, and we're in the lab 6 folder, and let's call it lead underscore Ohio, OH. This one is shapefile, is different from the CSV file. So when you click save, okay, and you want to add it to the ArcMap, yes. So now we have this as permanent file. But now we can remove the CSV file and also the counties Ohio. So this one contains the information, all of the information that we need. So now everything is prepared, the dataset is prepared, it's GIS ready, which was the most important part of our analysis. So the first thing is that I'm going to do is that I'm going to look at the histogram of the data, histogram of the some statistics of the building, year of the household. So if you right click on the header of the year house and then select the statistics, so this one shows the histogram of the buildings, right? households. So you can see that most of the buildings or households were built before the 1985 or 1990. Okay, and there are only very few counties that their built structure is later than 1990. Okay, so their median, so there are very few counties that so these are counties, number of the counties in different years that their age of building is between 1995 and 1955 and less than 2000. Okay, so there are very few counties with the newer structures. So on average, the mean year of the structure is 1969.9, and also a standard deviation of 8. And also here you can see, based on the proportion, you can see the histogram of the proportion, that most of the counties, less than 5% of the tested children had elevated blood level, and only very few counties they had more than 5% of the tested children with elevated blood level. Okay, and on average it's 2.73%, which is the proportion of the elevated blood level among the children that were tested for blood level. Okay, so let's close this window. So now let's test the association, visually compare the association between the proportion of the elevated blood level and also the year of the household in Ohio by plotting the association. So from table options here, if you select create graph, and using the scatter plot, so graph type is a scatter plot. So from which shapefile? From let Ohio only have one shapefile there, or we don't need to select anything, but the Y field should be the proportion, and the X field is age of the building. Okay, year of the household. So now we can see that, so it is obvious that there is a negative association between the proportion of the elevated blood level and age of household. So for counties with older, buildings or older structures, we have higher proportion of the elevated blood level, right? And for counties with newer structures, for example here 1995, we have lower proportion of the elevated blood level. So it seems that there is this is obvious that there is a negative association between these two. Okay, so we can add this to our map. For example, if let's remove this legend and uncheck add to legend, and also the color match with the layer. So the layer here is this color, so the color of this point should match with the layer. That's okay. And also, if instead of the rectangle we may need use circle, we can also change the size of the circle. I think 4 is okay. You can also add a trend line from add new function trend, and for the scatter plot, so you can see that there is a negative association. The trend in the data set is there is a negative association between age of buildings and proportion of elevated blood level. So if you click on show label, so it shows that the proportion from 1955 dropped from 4.34% or proportion to almost 0, and so you can add it to your map, but let's uncheck that. So we don't need this in this one, the trend, so let's uncheck that one as well. So click next. So here we can customize the graph. For example, the title that we want to have for the graph can be age of household versus elevated blood lead level. Okay, and you can also make it 3D, so I don't think it looks good, so 2D is better. Graph legend. So for each axis we can have a title. For example, for the y-axis you may change the title to, I don't know, the elevated. This one is proportion, so I say proportion is percentage, right? But elevated blood lead level, percentage of the elevated blood lead level. And also for the, which is visible, for the right we don't have anything. For the bottom we have probably household, and based on the year. Okay, so the age of the household based on the year. And we want to make it visible. For the top we don't have, and click finish. So this is our graph that can be added to your map. Okay, so when you make a map, for example, if you go to the layout view, and when you want to make a map, you can easily copy this, copy as graphic, and then here you can paste it. Okay, so it will be added to your map. Okay, so here, for example, if you select a county, if you select here dot, it shows that the corresponding county. Okay, for example, what county has the old household 1955 and also elevated blood lead level, the highest elevated blood lead level, you can select it here. So I think it's Cuyahoga County. So there is association between these two as well. We also need to add a histogram. So let me close this. Let Ohio, from table options, create graph. I want to add a histogram, which is here. Let Ohio shapefile, and which one is based on the, for example, based on the age of the household. So you can see that most of the households are built before 1986. Okay, so you can change number of the bins here, for example 9, 10. So you can see that there are very few households built after the year 1986. Okay, so 13. And for example, we also can change the title. Let's click next. The title to frequency of counties. Okay, because this shows the counties, how many counties. So the y-axis here shows count, number of the counties that built in this year. So the x-axis, which is in the bottom, probably we need to change this to I don't know, based on the year. Okay, so based on the year, how many counties, number of the counties in this year have been built. What else? I think everything looks good. Click finish. So again, you can also copy this and then paste it here. Okay, with the same size. When we export this, it will look much better, but you probably can put this here and also put this one here. Okay, so I want to add a map of the elevated blood lead level and also the map of the age of household. So first of all, let's right click here, properties, symbology, based on the quantities, based on the proportion. So we have very low, low, medium, high, very high of the elevated blood level. Okay, so between 0 and 1.5, some areas they have 4 to 8% of the elevated blood level. Apply OK. So you can see that Cuyahoga County is one of the counties with the highest elevated blood level, right? Between the values between 4.7 to 8.08%. And also, so let me click on full extent. I want to have another one about the age of household. Okay, so if I want to have another one, we have to insert a data frame. I'm gonna copy this here. Let's go to this section, and this one is based on the age of the household. Okay, based on the year of household. So the classification type, I want to have the interval equal. Okay, so click on classify and click equal interval. So click apply. Okay, so 1955, 1963. The interval is almost 8 years. This one is also 8 years, 8 year, 8 year, and 8 year. Okay, so that's the equal interval. Click apply and OK. So how can I make sure that these two have the same size? I can use guidelines. So if you click here and here, also here and here. So using this guideline, I can, let me put this here. I can snap this map to this guideline. Okay, and also I can snap this map to this guideline. Okay, click zoom to layer and click full extent, and I put it here. This one is also here. So both of them, they have the same size. So now I can move this one here and this one here. Or probably I can add a legend to this one, add a legend to this one, north arrow, a scale bar, the title for this, the title. So this one is based on the proportion. So here we can see that these areas have higher proportion, and based on the map, this one has the lowest, is the ages between 1955 and 1963, which makes sense according to the scatter plot. Okay, or for example, here we have again higher proportion and the age of the household is old. Okay, but here we have lower proportion, right? Lower proportion of the elevated blood level, and when we look at the age of the household, it's a new house, right? They have a newer structure of the household. Okay, so you can also use different colors if it's kind of confusing for you. For example, here I can use different color ramp like this, and probably flip the symbol. So this one shows that it's older. Okay, so the areas that have older like this, when we look at that, they have higher proportion. In general, they have higher proportion of the elevated blood level. So you can add the legend. Scale bar is because both of them are in the same size, one scale bar is okay, but the legend should be different because they have different color. A title for this, proportion of the elevated blood level, age of the household, title for this one, your information, north arrow, and then export it as a JPEG.